today we're here to celebrate the students who have made it through advanced Python. So today, pretty much we're here for graduation, where they are going to walk you through, and today's topic, drum roll, is gonna be application of GIS, data science and machine learning in health and in health data analysis. This is gonna be done by Emily Kimani, Brenda, Onyango, and Esther Wambui. So today we're here to celebrate them and actually listen to see what they have been learning all this time and how they can put it over as a presentation. So to you, Brenda, over to you. Please give us the presentation.
Thank you, everyone. I'd like to say thank you for being here. I really appreciate you taking your time to come and listen to us today. And we don't take that for granted. I would also like to say thank you, Jackie, for agreeing to moderate this and for being here, always being my cheerleader. George, as our trainer, I'm sure I speak for the rest of the team. You have been a tremendous help to our growth in data science, and we really want to appreciate you for that and to let you know that we appreciate the hand-holding that you've given us through this. I'll introduce myself. My name is Brenda Onyango. I'm an applications engineer in New York, and the rest of my team is Emily and Esther, like Jackie had said. And we're going to cover application of GIS, data science, and machine learning in health data analysis. So the choice of this project was, we have a GIS expert, who's Emily, and a public health expert, who is Esther. So we wanted to do a project that connects them, brings them together. And with that, we're able to capture one of the most, the trending topics right now, which is COVID-19. And before I proceed, I'd like to say, for those who are affected by COVID-19, we deeply feel for you. I'm sure my teammates share the sentiments, and we are with you in this. So here are the beautiful women that are presenting with me today. This is Emily, the data scientist and data analyst, same with Esther. So we need to know what data science is. And data science, as we have dealt with it, is the application of scientific methods, algorithms, and systems to extract knowledge from both structured and unstructured data. And with that, we apply it together with machine learning, which basically, well, we can all see the description, but machine learning in a few words is, you see how humans learn from experience. Computers don't do that. Computers usually need instructions to follow. So with machine learning, we change that. We change how machines operate through data. We feed it data, and with time, they begin to do their own actions. They begin to predict. That's how when you type something on your search, they're able to predict what you want to say. That's machine learning right there. And then the main highlight of this is the next step, which is GIS. We're just going to apply computer systems to capture, analyze, and present data on maps. In this case, it's going to be COVID data that we're going to map it around on a global scale, and it will allow us to have a better informational use based on application of geography. With that, we're connecting it with health data analysis, which refers to the analysis of the current and historical data to make predictions, because this is what we're going to feed our systems and then make the predictions from that and provide an actionable insight that will help us improve health data management, which is very key right now because it helps us in how we are going to respond to cases of COVID. All right, so that's all good and all, but now we need to understand what data analysis really entails. So a brief coverage is that it's a systematic application of both the logical and statistical methods to describe, condense, and evaluate cleaned data, emphasis being on the clean. You have to clean your data. And with that, I'll start by explaining briefly the data science process. And of the first step is going to be obtaining the data. So we got our data from OV datasets, which was our choice because it contains data for contributions of data from reputable health institutions. So after obtaining it, now we have to grab it, clean it, because our trainer, George, always emphasizes garbage in, garbage out. And for us to get accurate data presentation, we have to clean our data. So through this, we started by, first of all, we removed all the data that we didn't want, excessive columns and everything. I'll cover that in a little bit. We omitted any null values because that would throw off our averages and any final data that we will present. We also renamed some of the columns for clarity and everything. After that, we also converted some of the formats that we have. For example, if you're using geopandas, you have to convert it to geodata frames so that you're able to plot it on maps using the coordinate references. After that, we explored the data. This is where you examine the data. Not everything you have is going to make it onto what you're going to finally present. So that's where we make sense of the data that we have before we analyze it and present it to you. So this is how we determine what kind of visualization goes where. Not everything is best presented by a bar graph or a pie chart. That's why we use maps. So that's some of the things we were doing in exploring our data. Next, we go to the magic of all this, which is the modeling. So this is what George has trained us to become, the modeling of it. And on this part, this is going to be handled by Esther. So we went through our data, and this is where we were able to pick some of the main systems that we're going to use, how we model it, how we apply, for example, linear regression, and then applying it to forecasting. So that's where the modeling comes in. And finally, we get to interpret this data because not everybody wants to see all our numbers. What are the numbers telling us? Now you have to break it down to a non-technical presentation so that we can make an actionable use for it. So these are some of the libraries that we used. They're all very important if you're interested in data science. These are the list. We have pandas, which we use for the data manipulation and analysis. We have NumPy, we have Seaborn, we have Matplotlib for the graphs and the visualizations. We have folium, which is very interesting because it also applies to the geospatial data that we're going to use. Emily will cover that. We have geopandas, as I mentioned before, and then we have shapely geometry and scikit-learn, which was applied in the machine learning and statistical modeling that we're going to cover in this project. Now, onto the specifics of the objectives of this project is the intention was to determine the prevalence of the spread of COVID-19, both at a global and a national scale, because it's affecting countries differently. And the next is to assess the trend of the current death and infection rate. After that, we're going to present an in-depth analysis on the vaccine administration by region. So how is the vaccine in the more developed country or continents or the less developed ones? How is it in the US as compared to Kenya or Mozambique or Saudi Arabia, different countries? And then to predict the vaccination coverage in the US. So the US was our case study. So from that, as I mentioned, I'm going to cover more about the data source. And before that, kindly take note of our disclaimer. So the site that we got this for was OV Datasets. This is the website if you'd like to access more of that information, or you can get it on our GitHub that will be shared on the chat. So I'll get into this just a little bit. Remember, I mentioned preparation. And so this is some of the stats that we did in cleaning of our data. That's step 2 of the data process. So originally when we started, we had 97,000 rows and 60 columns. So we used the DF-shape model for that. And then we dropped the columns that we did not want using the DF drop. From that, we transitions to checking for the missing values. That would be terrible for our analysis if some of the data was missing because it would not be accurate. And then we replace some of the missing values with 0. After that, we renamed the columns because just because you get the data as it is does not mean you're going to use it like that. You can rename them so that it applies best to what you're trying to do to make it more relevant. And then we corrected the inaccurate data. For example, some rows were named continent instead of country. So see, that could throw us off. So those are the things we polished. They seem really minor, but they're very important in the final presentation. And then after that, we deleted all the rows that had their own names, and then we dropped them. So emphasis on this, check your data over and over again. You could miss something. So we kept checking them to make sure all the missing values are filled and nothing compromises our output today. And finally, after all the data was cleaned, just to show the importance, we came from 60 columns down to 30 columns. and our rows were down by almost 5,000 rows. So whatever is left, that is what we use in our presentation. And now I'm going to hand it over to Emily Kimani, who is a GIS expert, and she's going to knock your socks off because this is very interesting stuff. Thank you.
All right, sorry about that. Thank you all for coming in, and thank you for attending this presentation. I would like to first thank Brenda for that wonderful introduction and an overview of our project. Thank you to George for everything, for working with us, showing us what we are capable of. And when we started, this was like Greek, but now we are able to walk through these streets of data science and machine learning like pros. We are not yet there, but we know that we're going to be there. To my teammate, Esther and Brenda, thank you for the long hours that we have put in. Thank you for always being there whenever we want to, meet up and sacrificing everything we have to make this happen. Thanks, Jackie, for facilitating this. And all of you, thank you for being with us here. As I take you through the art of GIS, I want to start with explaining what GIS is. GIS is the geographic information system that uncovers that is about uncovering meaning and insight from within data. It's rapidly evolving and providing a whole new framework and process for understanding. And that is from Jack, who is the CEO of ESRI. And as we now go into the in-depth of what GIS is, it is a system that creates, manages, analyzes, and visualizes data for geographic positioning on the Earth's surface. So when you think of a geospatial system, it is the geography and the way anything is placed onto the surface of the Earth. So GIS connects data to a map, integrating location data where things are and all types of descriptive information about that data. So when we say something about Nairobi, so it is the location of Nairobi. Where is it located in Kenya or in the world? When you see it on the Earth's surface, you're able to visualize what that is. The picture that I have here shows the land, the flood zones, parcels, land cover, and elevation. When you put all these layers on top of the Earth's surface, you are able to come up with the bottom that shows how the rivers are, how the trees are, and how the houses are. And this one kind of gives you a picture of what it is. You're able to see it because when it's written on paper, it's really hard to visualize it. So GIS kind of helps you to visualize everything and kind of give you a picture. And as we know, pictures speaks 1,000 words, and that gives the whole everything, puts everything into perspective. The history of GIS. So GIS started as a concept. In the 1859, there was a cholera outbreak in London, and John Snow kind of was like, okay, what is this and what is going on? And when he started mapping all these cases onto a map, he was able to come up with the solution. He was able to fine tune and find that one water line is the one that was contaminated because all the cases were around that water line. And as the computers started evolving in the 1960s, computers started coming up, and there was development of computational, power started showing, and that's how GIS also started evolving in 1969. Jack Dartman founded the Environmental System Research Institute Incorporated. This is ESRI, which is the main firm that started to computerize and to give GIS the computer foundation that it has now. In 1981, ESRI developed ArcInform, that is a software that has now give GIS a very big perspective. Now it became commercial, and now everybody was able to kind of use it, and it was able to fine tune it depending on whether you are a land planner or an urban planner or you are real estate. This software can be streamlined to help you come up with any visualization or any analysis that you want with GIS data. And now, as we go into what GIS is used for in the recent, or in what we are using GIS for now, GIS is in everything. It is in agriculture, conservation, natural resources, public safety, transport. You can use GIS in everything. In real estate, you see that people are using GIS to see where the next big cash land is, and you are able to map out how the city is going to look like. Where are your utilities? Where are your buildings? Where is the next place that you can build a road, and how it's going to affect. GIS is also used in a lot of prediction, and this brings about the future of GIS. As we move towards web and cloud computing, we see that its integration with real-time information via the Internet of Things has become a platform relevant to almost every human endeavor. At this point, I believe that all of us, we have come into contact with Google Maps or GPS, and you can't go anywhere without them. You are able to print out a map that can take you from here to Boston, thousands of miles away, and you are able to drive from here to there without having to talk to anyone. The GIS is the platform, and the GPS is what is taking us to the next level. When you think about autonomous cars that are being processed or are being developed now, the platform for that will be GIS. When you think of smart cities, a city where you don't need to talk to anyone, buildings will be talking to you, you'll be asking direction from your phone. All this is on the background of GIS, and this will just, I believe it will just continue opening big world as we come to data science, as we go to machine learning. GIS will be incorporated in everything that we are doing. And after giving that history, now we tie this into why we chose GIS as part of our project. We see that previously, when you're using GIS, you need to have a specialized software to help you map the geospatial data. But now with geopandas, which is a free open source library, you're able to use the geospatial data to map anything to map it onto what you have. So data science and GIS come into marry together in geopandas. So geopandas is a basic use for data science, and you are able to use it to analyze and also for prediction. So in the extent of the common data type used in pandas, geopanda brings in the aspect of the geometric operation. Geoseries and geodata frames are the basics of geopandas. These operations are performed by Shapley library, and it depends on Fiona for file access and matplotlib for plotting. You can see that for a geopandas data frame, you have to have the column for geometry, and this is the coordinate system, the latitude and the longitude that you're able to map the data that you have. So if you have the map of Kenya, you must have the latitude and the longitude so that you can be able to visualize that on a map. When you are plotting using geopandas, the geopandas library has two inbuilt shapefile. One is a world shapefile that contains all the polygons for the countries of the world, and the other one is a point shapefile, a cities point shapefile that has all the points of all the capital cities of the world. So this one, you can see now the aspect I was talking about, the column for geometry is there. So when you talk about Tanzania, it gives you the coordinates for Tanzania, and that way you're able to map that onto the world, onto a world map. The next one is this one. I used the the matplotlib function, dot plot function, to map and to show you what the world shapefile contains. It contains all the countries of the world, and you have mapped them, and they have the boundaries and everything. So now with that, with the world shapefile, we are able now to bring in our COVID data set. Our COVID data set is merged onto the world shapefile. And with that, we performed a left join that we used to merge the COVID data. And from the merge, we are able to come up with an additional 3 columns: the continent, name of the country, and the geometry. And our main focus and our main interest was the geometry column that will help us map our COVID data onto the world map. This is the folium library that Brenda had talked about, and I will exit the presentation mode and go to here so that we can be able to see the time series. So a time series map is an interactive map that helps you to see the growth or the change of the data set that you have. Our data set was from December 31st, 2019, and it now with this time series data map, it's going to show us the change. So over here we have a legend that has the color, and with this color change, so as you get the data in, the color of the map will change. So from the beginning, we see that it's kind of the same color, so no data is here. But as the slide moves and the dates, you can see that the dates are moving on top there. So the time is that there is a change going on, and we see that the dates are changing, the color changes, and it continues. And now you can see some countries are appearing. You can see that Canada is showing up, countries are showing up. So as we continue to get the data, now the numbers are changing and the color of the map is changing. At the end of this, we see that in 2020 now, everything is showing up. A lot of countries are showing up because now we have a lot more data and we have a lot more COVID cases being reported. And at the end of our data set, the last day of our data set, we see that all this happens. You now can tell all the countries that are showing up. You can see what the changes are and how this has changed. So we go back to my presentation. And now we'll be visualizing the actual data set. We'll be using that to visualize our data. We are using choropleth map, that is a colored map that will help us to see the difference. You see now with the 92,000 rows of data that we have, we now can see it live. We can see what's happening without having to go through pages and pages of data. And this is the power of GIS, and this is the power of a map. It shows you in one map all that data that we have been working with. So you can see that all the world, the numbers in the data set is represented here. This one is for total cases of COVID in the world. And we broke that down into continents so that we can have a little bit of in-depth. And we see Europe, Russia has the biggest number. It has more cases. We go to Africa. We see that South Africa is a darker in color, meaning that they have more cases reported. And Asia, India had more cases being reported, cases of COVID. We go to the North American continent. USA has the darkest color here, meaning that it has more cases. South Africa, Brazil had more cases. And now we go to the total death in the world. The total death, I chose the different colors. It's the same. The main column that you're going to use is the total death. You can see that they are well represented. The total deaths in Europe, Russia had more cases, and thus it has a darker color. Africa, South Africa has more cases. And in Asia, the same thing, India had more cases, more total death cases reported. In South America, we have more Brazil having the largest total death. And in North America, we have US having more of that. We visualize the total vaccination in the world. And you can see that the data that we have projected this way. And as we go to the continent, Russia has more total vaccines that were reported in Europe. And in Africa, this one is different. We have Ethiopia and Tunisia having more cases, more total vaccinations, and Kenya shows up. Yay, yeah, Kenya. Total cases in Asia, we have China had more cases, more vaccination reported, and India also shows up. South America, we have Brazil has more, and North America has. And we used the bar chart to show us the top 10 most affected countries. For the legend, we have blue representing cases, red representing death, and green representing total vaccination per 100. United States and India leads, and Brazil follows closely. For the COVID total cases and total deaths per continent, blue represents the total case and red represents the total death. And we see that Asia and Europe, and then number 3 is North America. I have included the code. If anybody is interested, can go into details. The codes are there. If you have any questions, remember to type them on the chat and you can look at that as we go. So this one, we have the people vaccinated per continent, and Europe leads and North America follows. The top 10 countries, and blue has the top 10 countries with the percentage of population vaccinated. Blue is the vaccination administered, and red is total vaccination per 100. So we see that United States leads and United Kingdom follows closely. We are on this one, we are comparing the countries with the highest percentage vaccinated and the countries with the highest number of total vaccination administered. So the people vaccinated and people fully vaccinated, these terms might be confusing, but people vaccinated is anybody who has a COVID vaccination, whether it's the 1 dose or the 2 doses. And then the people fully vaccinated is all the people with both, with the 2 vaccination doses. And you can see that there is a difference. So in the United States, people vaccinated and then people fully vaccinated, followed by United Kingdom and then Brazil. Countries with the highest number of total vaccination administered, the United States is leading with the people vaccinated, and India follows, United Kingdom follows, is number 3. And we can see that, all this is represented. We have, at that point, with the visualization, we are able to come to see how our data looks. We are able to see now, okay, this is what the data, this is how our cleaned data looks like. We are able to understand how our data, because now this clean data and this visualization will help us as we go into the prediction part. And it will help us to predict now and to kind of come up with the models and run the models and come to a conclusion of our presentation and our project. So as we head out now, I'll give this to Esther Wambui, who is our public health specialist, and she will dig into the bulk of the project. And as we have said before, if you have any questions, type them out on the chat and we'll look at them after this. Thank you, Esther.
Esther, on mute. Can you talk to us, Esther?
Sorry about that. Thank you so much, Emily, for that wonderful presentation. As you have all heard, my name is Esther Wambui. I am a public health specialist. I've as well taken up Python programming language, and it's really interesting since I can use it in various aspects, and one being data analysis and machine learning. So as Emily has taken you through coverage of COVID-19 and observing how COVID-19 has affected us globally, I would like us to understand COVID-19 as a pandemic. So as we can see, these are all like what Emily has taken us through. So understanding COVID as a pandemic, we have all been using the term pandemic, and I would like us to understand that a pandemic is an epidemic that spreads across international boundaries. So when I say the word epidemic, I mean a very serious disease, and this disease, it spreads across a very short period of time and affects many people. And this quite fits how the description of COVID-19. The WHO as well, which is a body that gives us standards that we use to define medical terminology, gives us 3 pointers in order to identify and actually officially term a disease as a pandemic, which I have listed on this slide. So when we're looking at a pandemic, we look at it in both a medical point of view and a mathematical point of view. And I talk about mathematical point of view, we talk of how the disease is spreading. So in this case, we use this particular graph. And as you can see, for COVID, when it started, there was some gradual growth. This was because people had either not identified it as the disease, because maybe people were presenting with the symptoms but not being diagnosed with COVID, or the spread, fewer people had been infected. And as we know with infectious disease, if I get infected, I won't just spread it to one person, but I might spread it to 3 or 5 or more. And that leads to exponential growth of the disease. And this is clearly illustrated in the graph, whereby we plotted the maximum cases per date. And we can clearly see that initially there was a gradual growth and then exponential growth. And then earlier on the year, this curve had started to flatten, where we could see like there's decline. But it's very sad that we can see that this month this sudden growth, and this can be attributed to the Delta variant of the COVID-19. In addition to that curve, we also look at an epidemic curve. So this epidemic curve is mostly used by epidemiologists to try and figure out the source of an epidemic, as well as try and estimate the incubation period of this particular disease. So with this curve, we can see that there's a constant. You can see that between the period where there's low cases and then there's an increase, you see that those gaps are constant. And this is an indicator of the incubation period of that particular disease. And we can estimate it to be 2 weeks as we look at this graph. And that is the official incubation period that was stated for COVID-19. As well, this shape of curve indicates that this is an epidemic from a point source, which is the spread through this is a respiratory infection. So the source is one. So this is what the epidemic curve indicates. So we also try to look at the fatalities from COVID, and we see that there's a similar pattern, the fatalities and the cases. And as a data scientist, you always have to ask the right questions in order to be able to understand your data and to get good inference from it. So sometimes, yes, we know that people have died, that is general knowledge, but to be able to clearly prove it, we have to do a correlation, and we can clearly see a positive correlation of 0.89. This can prove you with no doubt that this is a fatal disease and needs measures need to be taken for it to just end. And as well, we looked into specific countries. This time we decided, yes, it's good to use maps. They're very interesting to look at. It's very good to visualize, but we need to understand this particular disease, how this disease is affecting a particular country. So in this case, we plotted both epidemic and logistic curves of countries. We have 4 countries that we sampled out of our data. And the first is the US. So we decided, because Brenda, it's always, home is always best. So Brenda and Emily are in the US, and they wanted to see, so how is COVID currently in the US? So we can see that initially the cases were very few, but then there was a sudden surge, a sudden rise in cases, and measures were put in place, and this led to the reduction of the cases. But we are seeing that there are signs that there's an upward trend of COVID. And I think this is just due to the variant, the new Delta variant. And you can as well see in the logistic curve that the US had really tried to flatten the curve, but something is happening and something needs to be done about it. And the same thing is in India. Remember this also, the spike when India had the spike in cases is illustrated in this graph, and they're currently trying to flatten their curve. As well, I am African, proudly Kenyan. We tried to look into data that we got from Kenya, and we can see both Kenya and South Africa have similar patterns, whereby we see that in a particular period in time, we have a rise in cases, then they fall, they drop down, then rise again, typical wave form. And we tried to look into these dates, and we realized that whenever, especially in Kenya, whenever they put lockdown measures, we find that the cases reduce. And then the measures are lifted, the cases rise. So is it that, our question was, is it that we need to, be locked down for the disease to end, or should us as Kenyans or Africans at large try and find better solutions instead of just, today we are well, then the next time, we just have reporting cases. Like even yesterday, we remember on the news, there was that, hospitals are now full, because of, when you can see they have a rise in cases. This logistic curve has never been flat. It's just rising and rising. So something needs to be done. And one of the things that I've mentioned is lockdown, and we wanted to see, does this lockdown really work? I mentioned, we noticed the cases in Kenya. A country that locked down quite earlier on was New Zealand. As you can see, just immediately when there was information that, hey, there's this disease going around and it's infectious, they decided to lock down. And lockdown is a method that has always worked. It's quarantining. It's not something that is new, but this time it was on a larger scale. It was quarantine on a larger scale. And New Zealand, as you can see from the lockdown, they have had fewer cases ever since. A country like Sweden did not lock down. They just implemented policies and, gave instructions to their citizens. This is how you need to interact in order to prevent spread of the disease, social distance. But for them, life went on, normal life, interacting, going to work, no staying at home or anything like that. And for some time it worked. But in 2021, the beginning of the year, the first quarter, we see that there was a rise in the cases. And we attribute this to maybe the fact that, international travel had started. So citizens who are not Swedish maybe would enter the country and not follow the guidelines. And I think they tried to curb this, as you can see, as time has moved, their cases are reducing and right now are quite low. In addition to lockdown, there are other measures that we can do. And one of the best proven measures to deal with a viral disease is vaccination. It's sad to say that most viral diseases do not have a cure, COVID-19 being one of them, coronavirus disease. So it's a viral disease. And as we can see, the reason for there not being a cure is because viruses tend to mutate. So you find a cure for this one today, and a few, because you see now we have, this here we had this variant, now we're talking about the Delta variant. So it's very hard within a short period of time to come up with a cure. So the best way is to prevent yourself from getting infected. I know there are various theories about the vaccination and everything, but since this is a measure that we have right now, I would advocate for it because it would not only help you, but would also help someone else in your family or your friends who are vulnerable to infection. Because some people get infected and are asymptomatic. They do not exhibit any signs, but for some it's fatal, or they really suffer. So that is why we have that concept of herd immunity, where that is why there's a push for vaccinations, that as a community, we are immune to infection. And this is the reason why we wanted to come up with a model that would make it easier for the vaccination process, whereby now we would be able to predict daily vaccinations. So we first of all tried and saw that the uptake of vaccine is quite well, as you can see with the growth of these curves, daily vaccinations and cumulative vaccinations. So as I mentioned, we wanted to come up with this model, and one of the main reasons is for the reason for this was the human resource allocation for vaccinations. Ever since this disease started, there has been the health sector has really taken a toll, and many health workers have really been affected. Some lost lives, and you might find sometimes even in medical or health facilities, they are short-staffed. So there needs to be a way whereby enough staff can be allocated to be able to offer this essential service, because we see that this is the best way that we can prevent infection from this disease, or we can reduce the infection rates, or we can flatten the curve. So this can as well be used to know how many for procurement, so that you can be able to know how many doses or how many vials do I need to order for this particular week, because we know that these vaccines that we have at the moment have a very short lifespan, because they expire at around 6 months or so. So you don't need to have so many, because you might have surplus, and then in turn, they become waste, and also in addition to them becoming waste, you need to dispose of them, and it's very costly to dispose such kind of medical waste. Now, in a larger scale, we were thinking, this model can be used by manufacturing companies. These companies that manufacture the vaccines, they can know how much to produce per particular day, just in order to prevent wastage and surplus. And as well, they can be able to logistically set aside some vaccination that they can use that they can provide to other countries who do not, or these countries who manufacture these vaccines can provide their surplus, in order for them, waiting for them until they're almost expiring is when now they think, oh, we can instead of waiting for them to expire completely, let's assist other countries, because we have seen even from our maps that COVID has affected all countries equally. But the problem is that not all countries are equal in terms of financial muscle or technology. So other countries who are not able to manufacture their vaccines can be assisted through such kinds of modeling. So the first thing you need to do is understand the kind of data that you have. So this is our data. It's daily data. As you can see on the left, it's dates and the vaccinations administered on that particular date. And this is the shape of how our data is. So this type of data is known as time series data. And time series data has a particular way in which you should analyze it. And also through that analysis, you are able to make better predictions. So time series data is not just, for COVID or this kind of data set. Throughout our lives, we have come across time series data. So weather data is time series, the stock prices, and even most of health data is time series. Patient attendance, patient vital signs, all that is an example of time series. And characteristics of this, in order to term it as time series, we see that the mean is always changing. It's never constant. It has a sort of trend, and it has seasonality. And sometimes you can find some data with structured breaks. An example of this is during the recession, the 2009 recession, you saw that stock prices plummeted, like they went down sharp. There was a sharp decline, and that is a break, like the trend was cut off. So that is an example of a structured break. So as you can see in our data, it shows a trend. So in the US, from January to mid-March, there was a rise. People were really, more and more people were getting the vaccine. Then again now, less and less people are getting vaccinated. When you see this, you need to have questions. So why? Is it that the entire population is vaccinated, or is it that people are experiencing bad effects from the vaccine, or is it that people are, the conspiracy theories are getting into people's heads? So as an epidemiologist or a public health specialist, you need to look into that and figure out why is this happening, because this is not good. In addition to that, we can see a sort of seasonality, whereby on the red plot is a moving average. So we can see a rise and fall in the moving average. And this is weekly. This happens weekly, whereby we see that in the beginning of the week, fewer people are getting vaccinated, say weekends, maybe on a Sunday. And more people get vaccinated maybe towards midweek, where maybe on a Wednesday there was a peak, then drops to over the weekend. So maybe most of the time when people are at work, that's when they get vaccinated, or when or maybe over the weekends people don't want to get injected. Now that might be one of the reasons. So, and you see, that is from this now we have seen that actually our data exhibits all these characteristics of time series. Another one keyword I need to let you figure to understand is that when time series data has a mean that changes, we always term it a non-stationary. We say that it is not stationary data. So we always need our data to be stationary for our machine learning models or statistical models to make better predictions. So in order to make a prediction, we always need to do these particular steps as follows. So we have our data. So we have the data that we need to train, which I have illustrated before, the time series data. We need to pre-process it, which I will explain. We need to make it better for the models to learn. Then we have a learning process. So our models need to learn. You give your model the data, and it learns the patterns of the particular data. And then you need to evaluate, as the model learns, to what percentage is it accurate or something like that. And from there, you can make predictions. Once you make predictions, if you have more data, you can retrain your model, repeat the process, and it's a cycle. So remember when I mentioned about the stationarity, we created a function to test for the stationarity of our data, and we found that our data was actually not stationary. And we made it stationary, and we used a Python function, the code is above, and made the data stationary by using referencing. We ran the function again, and we found that our data now is stationary. And as you can see on this graph, you see early on, we had a graph that had a trend that was going up and down, but now our data is constant. We can now use it. This is one of the processes in one of the steps in pre-processing our data. Another thing is we need to get the autoregressive value. So briefly, autoregression means that data points on a time series data are correlated. So this means that data from yesterday and today, there's a relationship between the data yesterday and today. There's a relationship between the data 3 days ago and today. And so we can use that relationship of data points to come up with a prediction. So that is why we say with time series, you can use past events to predict the future. That's why you can use past weather information to forecast weather. So in this case, we're also using past days data to predict the next days. So we need to get an autoregressive value, and we use a partial autocorrelation function. And in this is the graph that we used, and we found the value to be 1, whereby you can see the first point is the highest and the lowest is a 0, so it was 1. Also, we need to get a moving average value. Remember, I said the moving average is how the mean is moving over time, and that we use an autocorrelation function, and we got the value to be 1. So now the first models that we tried to use were statistical models, and this case, they require the previous values that I had mentioned earlier. So, and with statistical models, they just take up one value, they take up the dependent variable. So in this case, they will just take up the data that we have currently, the current time series data, and because now we already got the other values, we just input them in our models and then we train, then makes predictions. So the first one that we did was the autoregressive moving average. When we plotted it out, it kind of learned something, as you can see with the line at the end. This line is what the model learned, and it was not quite accurate. So we said, okay, what can we do better? So there was a better model, a statistical model that we also used, known as the seasonal ARIMA model, which now incorporates that concept of seasonality. And we can see that our model was able to learn better, was able to get the pattern of our data. So those are the 2 statistical methods we used. In addition to that, we also said, let's try and do a supervised machine learning model. So what does this mean by saying supervised machine learning? So we're trying to make our statistical models. You can even do the math on paper and create those models by yourself. But now when it comes to supervised machine learning, we are trying to make our computer learn. And we give it inputs and outputs because now it's supervised. So we give it the questions and the answers. Like you're given the questions and the answers, you cram all of them, then you go and do an exam. So that is the concept of supervised machine learning. So you give it the questions and the answers. Then once you do that, you give it a test. So the test has almost similar questions, but doesn't have the answers. So you tell it, okay, now answer, give us. Now those are what we call predictions. So the inputs of the questions would be the features, and now the outputs would be the labels. And in data science, we call this labeled data. We give the machine labeled data. So we need to create, because you remember we just have time series data, like just data. We don't have the features, we don't have the labels. So we need to create our own. So we first of all need, from the data that we have, we need to come up with features. And we need to look at features that actually are related to vaccinations. And from our columns, we chose to use the cases, deaths, and hospitalizations, because you see they're actually related. In addition to that, you also have to make sure that the features that you have chosen do not relate to each other, because this would overload your model and would cause errors. So from that, we are able to see that cases and deaths were correlated, we chose cases because it had a better relationship with the vaccinations. So it's always a good idea now to check for outliers, because an outlier would make your model to learn a wrong pattern, because that an outlier is sort of a wrong value. It's not supposed to be there. So we did not find this value that were outside the maximum. We did not term them as outliers because they were clustered together. So we did not remove any value from our data. In addition to doing all that, we need to do what is known as feature engineering. This means recreating features from the features we have, like engineering is just creating new features, and this helps in the performance of your model. And it also makes sure that whatever features or the questions or the input that you're giving to your machine is something that the machine can understand. So we were able to do some feature engineering. And from that, we're able to create 6 more features from just that column, the highlighted column, using the code here. We're able to create 6 more features. These are the previous day data, previous 3 days from 6 days previous. And now we're also able to create next day from the data we have. We're able to create all these features. And so now we have the features as listed, and now the label, now the answer would be the next day. And then from that, we now split. Remember I said you give it like the notes, which are like the training. So we split it into training and the testing, like the testing data. So we do the splitting. And then now you train your model on the features and then give the labels, then you test it to make the predictions. So from that, we're able to use these models. So basically the process of training machine learning models is more or less the same, as you'll figure out as you go through the code. It's more or less the same concept. So we use the decision tree model, and it was not quite accurate. It gave us a 59% level of accuracy. And so we decided to look at other models. So we looked at the random forest, which was almost similar to the decision tree. Linear regression. So the blue are what the model is supposed to get, right? But now the orange is what the model is telling us. So you can see that the linear regression was not quite accurate. And we also looked at another model known as the XGBoost. We see that this is actually like trying to understand, it's quite getting the pattern, getting some right, getting some wrong. So it has an accuracy of almost 75%. So this function is what we used to test the accuracy and the error, all that. This is the Python function we used to test for our models. And we decided to use the XGBoost because that's the best model we had for the data we have. So these are the figures that predicted. So we can see the last 2 columns. So these are the actual values, and this is what our model gave us the answer. So you can see there was some that it got, some that it didn't, but it was quite close to what the actual value was. So a case in point is where we did not have data on the 28th. So it was able to predict this figure for saying that on the 28th you might get this number of new vaccinations. And we thought this would be very useful because, as you can see, previously there are very few people who were getting vaccinated, but the 3rd previous day, like, there was a very large amount. So you can take this scenario whereby you have a short-staffed clinic. So you say, okay, we have many people getting vaccinated, so you increase the number of staff. Then after some time, you see, hey, today people very few have come, tomorrow very few people have come. Then you're like, then you people, you like half of you go to another department. Then if we had not predicted this, without this prediction, we would have done that. But since now we predicted that there was going to be a large number of people, like more than, like, almost double, but it was not exactly the exact value, because you remember our model is 75% accurate. This would now tell maybe the human resource manager, okay, since we're predicting that we might have more, let's not, cut down on the number of staff. And this would now make, work operations easier. People, it's very comfortable when you go and get vaccinated. You don't, struggle a lot, and even makes life much easier for staff. So something I would always ask, is if you would want to endeavor into data analysis or data science, always know that data is key. Like the more data you have, the more accurate your model gets. So with our project, we have worked with it for almost more like a month and some weeks, and we have used different data sets over and over again. And the more data we get, because you see now every day we get new data, the more accurate our models get. And there's this quote that all models are wrong, but some are useful. So that's a quote, and that's a quote our trainer always uses. He always says that. That's why you see we always try. You don't choose just one model and say that's what the one you want to use. Always try as many models as you can in order to get the best. And as always, you can always retrain and optimize your model. That's why I said the more data you get, feed it into your model, make it learn better. There are also some parameters in your model that you can adjust to make your accuracy measures improve. So with that, I would take it back to Brenda for the closing remarks. Thank you.
Thank you, Esther. That was fantastic. Emily, thank you as well. This is clearly a sign of all the work that we have put in the past few weeks, trying to understand machine learning and applying all of these modeling scenarios. So with that, we have a few takeaways. I'll try to keep it brief. So for the first one is, as they highlighted there. So one of our takeaways is that some regions had missing data, and we would recommend better reporting systems for analysis and prediction. The whole point of this data analysis, of this process, was to see how we can put it into actionable use. Now I'll go back to how I started in the introduction. And for here, we were able to realize that some regions, such as Africa, they didn't have very many numbers, but we acknowledge that there could be a different scenario at the grassroots level. So with better reporting systems, we'd be able to get more data, which we presume would make the outcome more accurate. On to the next one. From the data, we have realized that in the analysis of the regions, the more developed regions or the more developed countries versus the developing countries, there's a big disparity in the resource availability, which controls the adversity of the effects. For example, if you take India, for example, that's a developing country versus the US. Some of these regions, they don't have good reporting systems. If they don't report, the government doesn't get all the information it needs. So the response is lower. So meaning the more developed countries with better systems are bound to vaccinate faster and recover faster. So economic disparity is one of the other things that we saw as a major problem from the data that we handled. On to the final one. Tracking reinfection has also been a very big challenge, which touches on to the previous point, because when we take this factor into consideration, we consider that COVID-19 stopped the world socially and economically. And now on the recovery path, we need to know the rate of reinfection so that it can help different countries. For example, for New Zealand, they opened, they closed down, they reopened, and after analysis of data such as this, they decided to close again. So tracking reinfection is one of the main aspects that we have highlighted as important factors to consider when considering economic recovery for very many countries. So for that, that's our presentation. Again, I want to say thank you for everyone for being here. Thank you, George, for training us. Thank you to our teammates, our cheerleaders, Monica. Thank you all. Thank you, Esther and Emily. This has been quite the pleasure. So if you have any more questions, please feel free to ask us or post it on the chat. Thank you.
Thank you very much. I'm very proud. I cannot express enough, but you guys did a very wonderful job. You went and exceeded the expectation. That's an extra mile, and whoever is planning to join will be able to look at you guys as a template. This is what we can do. And this is something which we should be able to get in and get started now. Don't wait. If you keep on waiting, it's going to be too late for you. And I believe we can all do it together. Brenda, Emily, and Esther, thank you all so much for this good work. You did it, and as we can tell, you guys did a good job. Yeah, all the T's were crossed and all the I's were dotted. To me, this is almost like master's level material. Thank you so much. Thank you very much for the good job. I pass it back to Jackie. Thank you, Jackie.
Guys, you killed it. You killed it. And I'm going to put the human aspect of this, guys, so that you understand your presenters today. So for them to present this to you, various emotions have taken place. Some of them have included fear, and others have been, oh my God, am I good enough? Oh my God, we have too many slides. Oh my God, our time. But they have compiled stuff, and I am not a data scientist, and I was telling me God, but they made me get it. Like, I'm interested, I'm engaged, I'm locked. The manner in which they did their presentations, you saw the beauty of Brenda, you saw the beauty of Emily, you saw the beauty of Esther. I mean, they just did absolutely amazeballs in terms of their presentation. And remember, for them to go from introduction to Python to advanced Python, that is a big shift. And then for them to actually present what they have learned for 3 presenters in approximately 1 hour, that's a lot. You can imagine how much they had to pack and actually give you something that made sense. But how long did it take them to get to this spot? Now, if you are looking to get to this spot, it's not impossible. They started with knowing nothing, because we all start there, and then taking keen interest in introductory Python, and then also then after that, taking the advanced classes and working with MIGOT. So this is where they are. We will forever be with them in their journey, you know, career-wise, however they're going, entrepreneurially, wherever they're going. If anyone is in the audience and would like to join any of the classes, feel free then to get in touch with MIGOT. He's our instructor, and also your presenters. I mean, you can see that they're great at what they do. So also feel free to reach out to them for whatever tidbits you'd like about what they presented. And with that, I want to say thank you guys for coming. Thank you for your time. And thank you guys. MIGOT, I'm going to hand back to you.
Oh, thank you so much, Jackie. And we open it for question. You can ask anything you want, so long as it's nice.
That is kind of not a...
Hey, no condition, just ask. It's all good. We just trying to be funny here. Lighter moments. But again, ladies, you did really wonderful. Now let me just lay it out for you. The graduating, I'm calling it graduating class right now, because they're done with their project. They started, remind me, that was last year, December, right?
Mm-hmm.
So they went through a class for 40 days, introductory to Python. All of them came in without any knowledge of Python. And then once we finished that, it's a very rigorous program, they were able to come in and join the advanced class. We did advanced class for 3 months. And then within those 3 months, we covered AWS, which is Amazon Web Services. We covered Linux administration. We also covered Python programming on the administration side, as in scripting. We also did database management systems, and each time we applied projects to those. And then by the time we were done in 3 months, we dedicated anywhere between 1 month to 1.5 or even 2 months of just individual projects. So in addition to this combined effort of 3 people or 2 people doing a project, we also allow them to do individual projects. And we dedicate the time. They can tell you that sometimes you go even up to midnight or even up to 4 in the morning to make it work. So it's blood, sweat, and tears. but it's worth it. If you're in data science now, you know that's where things are. We talk of data science, we talk of machine learning, we talk of artificial intelligence. That's where you need to be. It does not take a rocket scientist. It just takes your dedication, talk to the right people, and then commit to it. Anybody can do it. I know it's kind of like, sound a little cliche, but it's possible, it can be done. Okay.
And there's a question, and Gaki Kasamba had asked a question earlier. Let me catch that for you. Somebody had asked, do you need an IT background? As I'm looking for Gaki's question, do you mind answering that about an IT background? Do you need an IT background? There's a question on that.
Okay, when we say IT background, that's normally a very broad, in my old English, I say very pregnant question. Now, IT background depends on, are you talking of, do you know how to type at the keyboard? Yes. Can you dedicate the time? Yes. Do you have at least some high school level education? Yes. Then IT background fall in place. So the rest will be your dedication, and there's a lot of resources online and will be available to help you. People come from, I believe, from nursing background, all straight to IT background. All they have to do is just dedicate and learn it. Sometimes you might not get it the first time, but don't despair, don't give up. It's almost like you're riding a bike. When the bike deflates, you probably want to pump it some more, and then you get an extra mile out of it. So to your question, you really do not need an IT background, but you need to be good at least with computers. And the rest will be history, will help you. So don't put it on the side that you want to go and maybe get a degree in information system or in computer science so that you can come and join. I did my master's in my classes in the master's program. Some people come from social work environment. They do statistics. They learn, they do databases. They learn through that. They're doing R programming, and they're doing Python programming. So it takes a village to bring this baby to where the baby needs to be. So IT background is okay to have, but it's not a requirement in my assessment of things, because I've been teaching this class for some time now.
And me God, I'll say, just for me from the outside looking in, because I'm not a data scientist, it's just also, if you have your mindset to learn something at this point in life, it's like whatever people learned in the back, whatever degrees, I mean, that is a beautiful thing, but we're in the age where we have to keep learning and then relearning. So if you have that mindset, you're good. My degree is in international business administration. And the tech jobs don't scare me. They say all this, whatever, and then they say any other related field, and I'm like, yeah, I got it. Even me. And I put myself there. The thing that you have to do is tell me, oh no, I said related field. Yeah. Even business, I am competing with you. Let's see who is getting this job between me and you. Let's take the interview together. Then now you decide for me. So sometimes just be ready to fight. If you have the information and you're willing to learn, present yourself and then see how that works. And it's today's learning. And I want to touch on a question on the chat. Gaki asks, on tracking vaccinated infections, in your opinion, how true is it that the info on vaccinated people who are succumbing to the virus is being suppressed? Who would like to field that question? Should I ask it again?
Yeah, go ahead. Try one more time, and maybe Esther will help us with that.
Okay, on tracking vaccinated infections, in your opinion, and I guess this can go anyway because it's just your opinion. I don't know that they're asking facts. Is what do you know? So it's kind of in your opinion, how true is it that the info on vaccinated people who are succumbing to the virus is being suppressed? Pretty much, are we being told the truth or are we being lied to based on what you found?
Okay, that's a good question. I'm gonna let Esther answer that, and it's a little bit political, so be very careful on that.
You delegated the politics.
Yes. Notice that, yes, and I would try as much as possible not to be political. I would talk in respect to the data that we have. Our data is from, as mentioned earlier, our world in data, and is got from the international bodies who report on vaccinations. So we cannot say that it's being suppressed. Maybe it's that it's not being considered, because when you go and you're sick, no one would ask you, were you vaccinated? It's not a data point that has been stated that it should be recorded and reported as data. So yes and no, we cannot tell that it has been suppressed because there's actually no reporting at all on that. Yeah, that's my opinion.
Yeah, I would add something to that.
And I would ask, is that regional? Because then when we're talking about it's not suppressed, is it a question? I think maybe in other parts of the world, it could be a question, and maybe at some point, maybe a requirement to go into work. I don't know. So I think that is a moving conversation in regards to suppression.
I want to add to that. And maybe, for vaccination, we can say we are just about a few months into it. And maybe eventually, as we continue to report this data, that we'll get more in-depth knowledge of how the data is. And as you say, it can be also, depending on what country the data is from, who is reporting it and who is in charge of reporting it. And as much as we don't want to say, there's a lot of politics around this. So
a lot of politics.
Yeah, so we just mapped what we had, and maybe eventually, as we are planning to continue feeding this data into our model and see how that changes everything as we go on.
Thank you. I see also Gaki states I'm in corporate event planning and I'm yearning for a change. Thank you so much for the encouragement. So Gaki, you're in the right forum, and in the right forums, if you keep joining the various talks that we have and the various meetings, I feel you'll see where you feel that you can gravitate to. And if we talk about time for change, I feel that the time for change is now. Just after the pandemic, the world is shifting. People are more open to various ideas. And at some point, I feel they lock themselves up. So if you're trying to shift things now in your life, this would be a nice time when people are willing to listen, employers are willing to listen, careers are shifting, because I feel give it 5 years, then we'll be locked into some type of pattern again, which may take a while then to shift. It's not that it's going to be impossible, it most probably will be harder. So now would be a good time. I see, was it Paul who had his hand up? Paul, did you have your hand up, or was I imagining? I may have. Let me just take a peek at the chart I see. And everyone says, good job, good job, good job. I see Chris McGass saying, good job, ladies. Janabi Odongo says the same. Henry Muruga says, I've been encouraged from the God's work. I stopped at Python learning at the assignment number 3. So we have to hold Henry accountable.
Henry has to come back.
and do his homework.
Yeah, do your homework from that homework 3, Henry.
There you go. So he has publicly stated that he will finish. So Henry, we are holding you accountable to you are doing your homework, and you have me got. So thank you. That makes sense. It isn't required a question during admissions, then it would make sense. Okay. So I feel for the chat, what people are saying is it's great jobs. I think we've caught most of the questions that we needed. For the people sitting here, is there anyone with a question right now? You have me got, and you have the panel. Smart data scientists right in front of you. Any questions? Or forever hold your peace? Okay. Angela Kimani says, good job, girls. Okay, going once, going twice. Questions? Okay, well, Wanjiru, yes, please go ahead. Wanjiru Wangigi.
Yeah, I got a question in regard to the teaching he was talking about. Is it kind of charged? Do you have to pay for the program?
We got over to you.
For the advanced class?
Yes.
Okay, so first of all, the introductory part of the class is, I offer that for free. Okay, and just to encourage people to get started with it. And then if they do very well and they're based in Africa, and they show me that they really can make it to the next level, I normally give partial and sometimes even full scholarship. So there are people who have gone through the program with actually full scholarship and finished. So I take the hit And then if they are based in the US or Canada or Australia or somewhere in Europe, we can work with them, but we try to see if they can also pay something small which can help us, even buy a piece of chalk or pay the Zoom. So I have a lot of students who have paid through, and they also help us support other students who don't pay. So it's not about making the money, just listen. I mean, there are programs you can go if you want. Some of them are free, some of them, they will not be a one-to-one basis. But some of them, they'll probably charge you up to 10,000 just the same time, but you not come up with anything. So the reason why we actually try to do that is to be able to encourage us to be able to get into this field. It's a field which is pretty much open and it's yearning for people to join. And you stand a very good chance of making money if you come in and join it early enough so that you can gain the experience you need. You don't have to be a data scientist, or you don't have to be a computer scientist or information system. You can come into this field from Bachelor of Art, or you could have been a priest. Now you want to decide, or you just decide you want to come in and learn something which can help you improve. So it's doable. Okay. So the advanced class normally is not free, but depends on how you perform, where you are located. And there are so many other variables which I cannot tell you, but when we're in there, then you can learn. I mean, I see the dedication, and then I issue scholarship. Some of the students are here, they'll tell you. Some of them, they pay because they want to support the cause. So at the end of the day, we build a community.
And what you state is very important. We got when we talk about building the community. So I'd say to the people who even are just curious, like the number of times I've shown up, I'm still not a data scientist, but I think I'm being forced into their world by force by fire. So sometimes it's just showing up and having conversations, and then when he gives the introductory Python classes, try and see, can you do it? What is your dedication? And then at the end of the day, much as we have presentations, from Brenda, Emily, Esther, I mean, there's also, I see Lucy online. When he says build a community, we actually hold each other's hands, where we are brothers and sisters, truly brothers and sisters. If somebody is looking for work, they're trying to do something, we hold each other's hands and make sure that we're pushing to the next level. So that is equally important. As well as getting the education and the knowledge, it's also having a community of like-minded people who hold your hand and walk with you as well, which is really key.
Yeah, and to your point, Jackie, when we do these classes, sometimes I know most of us are parents, some of us are students, but above all, there's a goal you want to accomplish or you want to achieve. Mm-hmm. So you want to look at it like every minute you spend, you want to get something out of it. Mm-hmm. So when you join a class, if you come with all the dedication, somebody like me on the other end, I'll see that into you. And I'll try to push you. I always push. Some people say I really push too much, but I try to push so that it can be very beneficial for you. They'll tell you, I push, but I push with a lot of love. So if you want to join, come and join. This is a good time. I mean, it's almost like you have a toolbox. You have a pliers in there, you have a spanner in there, but you need to have more so you can, if in case something shifts around, then you can use a wrench. Or if something turns around, then you can use a screwdriver. Now take that toolbox and bring it to your career. You don't want to just have one thing, which maybe one day might not work for you. When I grow old, I might not be able to do nursing as much as when I was young, because maybe it could be much more on the physical end of things. So maybe I would like to be able to just teach. So sometimes being a nurse and being a teacher it's not a bad thing. You just have to maintain the 2 certifications. So that's where you probably also want to look at things from. It's very helpful to have more than one trade. And I know people are busy, but if you can, it's good. I used to have a friend. She passed on last year. She was a dentist. She moved into Texas, and then she went into nursing, because being a dentist, sometimes you require a lot of work. So she needed the nursing degree real quick while she was transforming from New York. So she ended up being a dentist and a nurse. So being a nurse, she can work, and being a dentist, she can also work. So have a business and then do the other things. So it works differently for everybody, but that's just my analogy. You don't have to do what I say, but at least now you have some idea.
Hi guys, this is Sylvanus. Hey George.
Hey Silvan, what's up, man? Nice to see you.
Yeah, no man. Yeah, man. First, thank you guys for doing this. Thank you for doing this. And I'm just sorry I joined a little late. I wanted to join at the beginning, but somehow it never crossed my mind that this is starting at 12. Otherwise, I'm saying again, I want to applaud you one more time for just doing this, helping people. And I'm so interested in that Python class. And so I would like to know exactly what are your schedules for the beginners, especially.
Okay, thank you very much. So just for the record, me and Silvanus, we go way back over 20 years ago when we just came into the country. So yeah. Silvanus, thank you very much for joining. Now the schedule for this class is very flexible. When we normally start, we start with Python, we do everything on Zoom. And then we do everything also as in homework, and all the reading materials are available for all the students on Google Classroom. And during that period, it could be last time we did for 50 days. The previous time before that, we did it for 40 days. The first time ever we did it for 30 days. So each time we give like about 3 sessions for the Zoom.
Okay.
And one session could be like 2 weeks into the class, and each session lasts anywhere between 2 hours to at least 3, even sometimes 4 hours. Every session is recorded and we post it on YouTube. So even if you miss it, you can always go back and watch it. And we put it that way so that it can be flexible for everybody, and it's free. So it's just a matter of somebody getting the time to do it.
Okay.
Yes, sir.
Okay, sounds good. Yeah, thank you.
Oh, you're welcome, man. By the way, you're welcome, man. So anytime you're ready, let me know.
Definitely, yeah.
Yes, sir.
All right.
Okay. Any other question? Looks up like yeah, Jackie, looks like everybody, we answered everything. Looks very nice.
Yeah.
Everybody's happy. Is there anything?
Kennedy Wambui is looking for the YouTube channel name, please. Do you mind dropping a link to the YouTube channel where this information will be found after the fact? Or do you just do you want to drop your number so that Kennedy can get in touch with you, Miguel?
Oh, okay. So the YouTube name is going to be under Open Source IT 2020.
Let me type that.
Yeah.
Please correct me if I'm wrong. I'm going to go ahead and type it now. So open source. Open. It's one word combined.
All one word combined.
Open source what?
IT, like information technology.
Open source IT technology.
No, open source IT.
That's it.
Yeah.
Then you say 2020.
2020, yeah.
Okay. Okay. Take a peek and tell me if I did it right.
Okay, where did you type it?
On the chat.
Yeah, that's the one, right?
Okay.
Yes.
Salome is asking, when is the next free class?
Very
Salome,
soon,
you've been in the other classes before.
You know,
Salome needs to do her homework.
Jackie, the next free class actually dedicated to Salome.
Oh, okay.
Yeah,
No, that's
so,
why she's asking.
Yeah, it's
Okay.
gonna be Salome's. So I'm gonna be looking for Salome, and Salome has to
Salome's Python class.
Yeah, it's gonna be.
You call it that.
In about a month or two, we will announce it, and Salome will be the the reason why we have it.
So she has to
monitor.
And she has to finish all her homework and graduate with a party. Okay, Salome,
Yes.
we will be watching you, and then we're looking forward to your success party at the end.
Yes, very good. I'm very excited to have everybody. Let's use each other to network. Let's use each other to network. It's very important, so that if I know I can only do A, somebody probably can do C or D. So that's the energy we have. And by the way, WhatsApp is also free. So you can even use WhatsApp and Facebook. Those are all free. So if we cannot use those networks, then what are we good for?
Yeah, we can't just use it for spreading jokes and
yeah, we keep on talking about the success of the Indian people, the Chinese and all that, but we sit on our own gold mine.
It was nice to see it on Tech Tips, the one who got the H-1B visa. That was a really good post today by Josh.
Yeah.
Yeah, it's nice when we start doing things like that, getting those visas.
Fantastic. I mean, we cannot change the whole world, but the one soul we change is good to go.
Yeah.
All you can do, the best you can do is just turn around and do the same thing to somebody else. If you try to change the world, it's not going to happen. Just one soul at a time.
Absolutely.
Yes. Mm-hmm. So with that said, Esther, Emily, and Brenda,
yes.
Any other last word you have? Something you forgot you want to mention?
Where can you be reached?
Oh. Okay. For me, I'll say anyone who wants to come into this, it's not Greek or Arabic, you can do it. Just commit your time and dedicate your time. Migot is the one guy that is ever available. He will work with you. I had some intro on Python, but I never used it as much. But joined the class in November last year, and this is where I am right now. So it's doable. We can do this. There's so much out there, and I believe it's just the beginning. For us, we are hoping to continue and get into so much more. There's so much information, especially with COVID happening. There's so much information on the internet. A lot of classes have been uploaded online. So we were able to get a lot of our data or our information in the internet. And as you get into these, the class will only give you about 60, or I would say 50% you learn in class, but the other 50, you have to go dig it yourself. You have to go look for it yourself. You have to, keep in touch with your classmates. You can't do this by yourself. That's one thing for sure. You cannot do it by yourself. You have to network. You have to talk to your classmates. We have to share. We have kamukunjis. We came up with kamukunjis that are study groups that we have. You have to spend time with these for it to get into you. We still are not yet there, but I see my husband.
Yeah.
Oh my God.
Yeah. By the way, every good thing you see, even the honey,
yeah,
it takes the bees to make it. It's
sure.
not overnight. So Mr. So-and-so is complaining.
Yeah.
It's all good, man. Hey, by the way, he did a good job because he let you finish. So I know he's doing that in good taste.
Yeah. Yeah. So thank you so much. And we are not yet even done. We're just going to continue. So excited. Esther and Brenda, man, it's been real. It was nice.
Oh, it has.
Yeah.
You can reach me on LinkedIn, Emily Kimani on LinkedIn, and GitHub. Look for Emily Kimani. You'll find us there. We are going to upload the notebook and the data on GitHub after we finish cleaning it up. And you can reach out to us, you know, whatever question you have, we can do this. We are going to work with you and help each other to get where we need to be. Brenda, to you.
I just want to say thank you guys for joining today and sparing your time to witness us do this. As Emily said, it's more like an iteration of what everyone has said. This takes a lot of dedication. I started as well last year. I had no IT background whatsoever. And the bulk of what I know now in Python is all George. And no one's exaggerating anything, legit. You could email George at 11 p.m. and he'll be available to make that code work. And you're not going to bed until it works. So it's that dedication that you get from your trainer and your, because usually it's a group project that motivates you to do it even more. Do it yourself, because now you're not just doing it yourself, you're doing it for everyone on your team. So it's been quite the journey. It's been an experience, and it's a pleasure to work with all of you. Emily and Esther, thank you. It's been a pleasure.
Thank you, Brenda. Esther, you want to say something? Today,
Yeah, I'll just
today
add.
your name is Migot today, Esther.
And real quick before Esther, Brenda, please drop how they can reach you in the case that they want to reach you. Do you mind dropping that in the chat?
Sure.
Thank you.
Yeah, she does this. Yes, my name is Esther Wambui. Don't mind knowing that it's been a challenge even to start, even at the beginning of the presentation. But I'm so grateful because I had no IT background as well, because I come from public health, and if anyone knows about public health, we don't deal with computers in any way, shape, or form. But through the class, through George being there to handhold me and to show me from the word hello world to being able to write a function and do data analysis with Python. It's just a journey that takes someone to have had to assist you, and you being open to learn, being able to do the work. It's not hard. And I'm also grateful that you all took your time to come and listen to us, to come and listen to what we had to say. I do not take it for granted. Thank you so much. If you would want to reach out to contact me, if you have any questions or would like further information on our project, I will post my GitHub link on the chat. It's S Wambui, and my LinkedIn is Esther Wambui. Thank you.
Thank you very much for all the attributes, and thank you to the audience. By the way, Judy Kimani, we're still waiting for you to come back. Sister. All right.
Sister.
Yeah, so with all that said, Jackie, I think we are good to go, and it's okay. All this is recorded, and we'll go ahead and post it on YouTube so you can share the moment. And thank you very much for everything and all the support.
Thank you. Because I want to add something real quick as well, or to the people in the audience. You know, you guys today, you watched a beautiful presentation. If you gravitated to any of the presenters, like sometimes it's also in understanding the human behind the presentation, the human being behind data science. So if you gravitated to any of them, feel free to reach out and actually have a conversation, because if they actually maybe tell you their stories before the data science and alongside the data science, if you're in a place where you're feeling stuck about shifting in your life, sometimes adding the human connection, and each of these young ladies here today have so much to add to the fact that they did learn data science, but so much else was going on. So maybe get with them also on their human side to understand if you need to shift, how did they actually shift? And that's all we got.
Thank you. Thank you.
Thank you.
Thank you. Looks like we covered everything. Everything. All right, guys, you all have a good time. And I know it's Saturday, so don't do anything I won't do. Behave well, and whatever you drink in moderation.
Oh, yeah. And
Yeah.
some need to drink too.
All right. Thank you very much. And you all have a good and blessed day.
It's a
Have a good day.
Thank you.
Bye.
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 Thank you.
Bye-bye.